There's one very common problem in Google Sheets. The moment you start writing a code, everything works until something changes. You reorder columns or add a new field, or slightly adjust the structure and your code breaks. And the worst part is that every single time you have to go back into the code and fix everything manually. What if you could write universal code that doesn't depend on column position, doesn't break when things change, and can be adjusted in just 5 seconds without even opening the code? In this video, I'll show you a method that completely changes the way you work with a script. This is a coordinate-free approach to reading and writing data. So let's start with the setup. First, we'll prepare the structure, and only after that we'll cover everything with code. I have this form, and separately I have a table that acts as an archive where we will store the data. And instead of jumping straight into coding, I first create a separate configuration sheet. I'll call it Localizer, because in a way we're doing something similar to localization. For example, in one place a field might be called identifier, in another place it might be called ID, so we need a way to connect them. So here's the structure I create. In the first column will be universal keys, and the name of this column will be key. Second one, I write the field names as appear in my form, and the name of this field will be form. In the third column, I write the field names from the archive, basically the headers of the table where the data will be stored. Now comes interesting part. In the second column, I don't just write only the names. I also define the direction of where to get to the value from. I write it using commas. The first value is the header itself. The second is direction, and the third is how many cells to move. For example, in my form the header is in one cell, and the value is located one cell to the right from it. So I write right, comma, 1, and I define this logic for each field. So instead of hard coding coordinates in the code, I describe all the logic directly in the table. And at the very end of this configuration, I add a special keyword stop. This will act as a signal for the code that the configuration is finished and there is nothing more to process. At this point, the setup is fully complete. And now we can move on to the code. I open AppScript and create a class that will handle working with the spreadsheet. I'll call it InputKeeper. Its purpose is to give us a simple and universal way to get data. Here's what the first method looks like. Everything here is very straightforward. We open the spreadsheet, get the required sheet, and then if we need the sheet itself, we return it. If we need the data, we return the sheet along with its values. This is our base entry point, and from here we'll start building logic without using any coordinates. Now let's create the main function, save input to archive, and see what our getInputSheet method actually returns. First, we define the variables, and in the console we will see that values is just a regular array. And this is a very important point, because now we can find any information inside this array. To do this, we create a separate function, findHeaderCoordinates. Its purpose is to find the first occurrence of a given word and return its coordinates. Here's what it looks like. How it works. First, we iterate through all rows of the array. Each row is a separate array. Then we iterate through each element inside that row. At this point, we are no longer working with array, but with actual values. And once we find the target word, for example, the function immediately returns its coordinates. So now we're no longer tied to A1, B2 or any fixed positions. We search for data based on its meaning, and this is the key idea behind the entire approach. Now let's return to our configuration sheet. Our task is to learn how to read it. So in our save input sheet to archive function, we switch to the configuration sheet. Right now, what we're interested in is collecting data in a key-value format, like we defined earlier. For this, we create a separate function, buildKeyValueMapUntilStop. Its purpose is to find two headers. The first one is the key, and the second one is the name of our form. After that, it will move down the table and stop when it encounters the word stop. To find the headers, we use our findHeaderCoordinate function. It returns the coordinates from which we start reading. Next, we define the key column and the value column. The starting row is header row plus 1. Then we create an object to store the collected data. To iterate through the tables, we use a while loop that continues until it finds the word stop. At the end of iteration, we increase row index to move down the table. We call this function, pass the values and the two headers, key and the form name, and we get an object where all the information is collected. But there's one detail. In this form, the data is not yet very convenient to work with. Right now we only have a key and a raw value string. What we need is to split this value into logical parts, headers, direction and number of steps. And this is exactly what we will do in the next step. Now let's make our data more convenient to work with. Right now we only have a simple string, but we need to split it into separate parts. For this we create a new function. Basically we take the previous function and improve it slightly. Here what it looks like. What changed? We simply take our values and split it by commas. As a result we get three separate parts: header, direction and step. Now instead of a simple string we store a full object, and let's see what we get. We call this function and log the result in the console. As you can see, now we don't just have a text, but a structured object where each case contains header, direction and number of steps. And with this format we can start building a full logic without coordinates. Now that we have all necessary information, we can create a function to read values based on our headers. Let's call it getValueByHeaderNavigation. It's very simple. We pass the function on an array of values and an object containing the headers, direction and step. First define the headers coordinates using the findHeaderCoordinates function, then we check the direction. If moving down, add the step to the row index. If moving right, add the step to the column index. Here how it looks in the code. This way we can easily get any value from the sheet without hard-coded coordinates, simply using our case: headers, direction and step. This is the essence of coordinate-free data reading. Now let's create a function that will read all data from the sheet. We'll call it resolvePreparedKeyValueMap. Here what's happened. We loop through all the keys in our configuration. For each key we take its configuration, header, direction, step. We pass it to getValueByHeaderNavigation, which returns the actual value from the sheet. We store the result in a new object called data. Here's the code. Now let's run this function and see what we get. As you can see, we now have all the complete information from the sheet structured by case and ready for further use. The next step, we need to post this information to the archive. But before that, we need to find the coordinates for our archive map. For this, we'll create the function getInputCoordinates. As you can see, here we simply return an object with coordinates for each archive key. Now we have the full structure. We can read data from the sheet without hard-coded coordinates, know exactly where each value is, and be confident where to write it in the archive. Now let's gradually put everything together in our function. First, we read data from our sheets. Next, we prepare the form configuration. And now the archive configuration. That's it, all the necessary data is ready. Now we just need to write it to the archive. First, we add a new row so we don't overwrite existing data. Now we loop through our archive configuration and post the values from form data. And we run the code. As you can see, the data is successfully saved. If we change the order of columns in the archive, the code still works and the data is written correctly. If we need to add a new field, for example city, we simply add it to the archive and to the localization sheet. Run the code. And everything works without any data loss. In this way, you can create a universal algorithm that doesn't need to be rewritten every time the table changes. Instead of writing the code from scratch, you just configure it via the settings sheet. And this is the true power of coordinates-free reading and posting of data in Google Sheets. You can find the code on GitHub. The link will be in the description under this video. In the next video, I'll show you how to store data in a single sheet like almost a database. This method will help you forget about the 10 million cell limit. If you don't want to miss it, make sure to subscribe.